Okay, we are seeing about self-joins. The last class we have completed two examples on top of self-joins. So here, if you want to compare the table by itself, it is called as what? Comparing a single column value by itself within the table. There is another thing that we have to discuss, which is comparing multiple column values to each other within the table. Okay, 1 minute. Yes. So comparing multiple values to each other within the table, right? So we will discuss this today. So I will take a small example on this. So the example is going to be like, so write a query to display managers and their employees from EMP. Now I am considering the second one, which is what? Comparing multiple column values to each other within the table. For example, let us say that I have the employee table. So in my employee table there are many columns, right? So there are many columns in the employee tables, right? So there will be the employee number column, employee name column, manager column, hire date column. So many columns are there. So I will be comparing the values between two columns. I can compare these two columns, right? I can compare these two columns. So based upon that, I will be expecting the required result set or the required resultant table, right? So if you look at this example, if you just observe this example closely, I just want to display managers and their employees, right? Managers and their respective employees. For example, in any company, so the hierarchy will be like there will be, you see few managers, you see few team leaders, and you see developers or the teammates. Okay? Even though they are managers, even though they are team leaders, but with respect to the company, everyone are employees. Even manager is also an employee, team leaders, they are also employees, developers or teammates, they are also an employee, right? And I want to take the managers. So under managers, okay, who are the employees under the particular manager? So there can be many number of managers. For example, let us say there can be 5 managers. Under each and every managers, how many employees are attached to one manager, or how many employees are falling under one manager? Okay, to see, let me take the example. Set page size as 100. Set lines to select from. I see. So these are my employee. This is my employee table, right? So in my employee table, I have these many columns. You have the employee name. You have the job. This is the manager ID. This is the manager ID. You see, John and the John manager ID is 4, which means 4 is the employee. So this is also representing an employee ID, but this employee ID is what is defining the respective managers for these particular employees. For John, since the manager ID is 4, okay, Sarah is the manager. Right? For Jane, 4, Sarah is the manager. Again for Mike, 4, Sarah is the manager. Again for Sarah, 8. For Sarah, Emily is the manager. Right? And for Chris, the MGR ID is 9. 9 is what? Dan is the manager. For Dan, 10. 10 is the manager. Olivia is the manager. Okay, I want to list out the employee names and their respective managers. How I can draft a query on this? I can simply say select. Right, I'm going to take alias names also. Alias names are like m dot e name as managers, comma. Second one is e dot e name as employees, okay, from EMP. Okay, just 1 minute. From EMP E join EMP. So I'm selecting the employee table. I'm using the join key as the join itself, right? So this is the alias name for so right now by now you got to know that whenever you're using the alias names, so the virtual tables are going to get created. So there will be two virtual tables, okay? One is the virtual tables by the name of E and the second one is virtual table by the name of M. So this is going to do what? This is going to do something like this behind the scenes. So this is what happens behind the scenes. The moment you do this, if there is any table, okay, in our example the table name is what? The employee table, right? And since you are using the alias names as E and M, two virtual tables are going to get created. So this one virtual table is for the E. This virtual table is for what? Is for the M. Two virtual tables are going to get created, E and M. And in each and every virtual table there are how many columns? The columns are like 1 2 3 4 5 6 7 8. There are 8 columns, right? So this is, you have 8 columns here and you have what? You have 8 columns here, 8 columns and 8 columns, right? And what I'm doing, so here I am just fetching m dot employee name as managers, e dot employee name as employees. So here there is a column called e name, and here also there is a column called e name. I just want to select m dot employee name as managers, e dot employee name as employees, right? So that I will be getting to see two columns by the name of managers and employees. So only two columns will be coming in the resultant table set. Only two columns will be coming in the resultant table set, right? After this, I am just extending my query to further. Just want to extend my query like this. So I have used the join key, right? So after the join key, I am going to use this on. Okay, what I want to do, I want to do the alias m dot employee number, right? Employee number I am joining with what? E dot mgr, E dot mgr. If you see, I have got the list of managers, I have got the list of employees, right? So why only two columns? I'm just selecting how many columns? One column as managers and second column as employees. So two columns, managers columns and employees columns. I mean the column by the name of managers, column by the name of employees. Okay, and just you need to focus on this particular condition. What does the condition says? You are comparing the employee number of m virtual table with what manager ID of the employee table. Okay, I just take this table as an example. Just take this table as an example, not this one. Let me consider only two things here. select select employee name as managers, select EMP number, okay, employee EMP number, E name and MGR. Name. I will just consider three columns for simplicity. See what is happening. So an employee table is getting created. Okay, the employee table is getting created by the name of these columns. Right? Yeah. So this is by the name of E, and this is by the name of M. So what is the joining condition that you have taken here? The joining condition says, so this is the joining condition. So this is the joining condition. So here, if you observe, okay, you are working on with two different columns, right? So one column is M dot employee number. Okay? So M, so this is M. This is M. So you are dealing with the employee numbers in the first column. Employee numbers, right? Second one is E dot MGR. So this is C, you're dealing with this column. So you're dealing with two different columns. So as per our discussion, what was our discussion? Comparing multiple column values to each other within the same table. I can say that these both are same tables since they are just differing virtually, but the data is all the data is completely same, isn't it? So you are comparing this, you're comparing the column, different columns within the same table, right? This is also a kind of self-check. What is the comparison? Okay, M dot employee number. So this is the employee number, right? So this employee number is compared with the manager ID of this E. So every row, every value will be compared with the remaining value. So one will be compared with one will be compared, everything will be compared, right? No matching will be common. Likewise, and this two will be compared with everything. This two will be compared with every manager ID. Right? No matching will be found. Okay, then the three will be compared. No matching will be found. But you can see some matching. Okay, when the four is getting compared, four is going to get compared with this one. Right? So this will be joined. Okay, so I'm looking for only I'm looking for the uh, m dot e name, right, as managers, right? So this is m, this is m, okay, m dot e name. Okay, now there is a matching found, right? So this Sarah will be joined with, okay, John, since there is a matching. Likewise, there is another matching. Four will be compared with the second four. Okay, this Sarah will be matched with Jane. Okay, then Sarah will be matched with Mike. Okay, done. Next thing is five. For these four, these three are matching. Three are matching. Okay. Then for five, you take five. These two will be matching, right? This one and along with this one. So you get to see Chris will be mapped with Amy. Chris will be mapped with David. Amy. The opposite or what? Okay, correct. Chris is matching with Amy and Chris is matching with David. Okay, next thing is if you take the six. Okay, there is no matching for six. Seven, there is no matching for seven, and eight. You see eight, right? Dan is going to get mapped with Sarah. Okay, and if you see nine, okay, nine is here. Sorry. Emily is mapping with Sarah. Emily is mapping with Sarah. Emily is mapping with. Emily is mapping with. Actually, it is going to compare each value to all the values in the next column. Each value will be compared. So I'm just looking for the exact matching. That's why keep it simple. Keep it simple. I'm just looking for the exact matching. So Sarah. Okay, Sarah is done. Next one is, let us see, nine. Okay, so nine is here. Dan is getting mapped with Chris. At last, you have what? You have the 10. 10 is what? Olivia, right? Olivia is getting mapped with Dan. So this is the output. Okay, we see the output. It is very much self-explanatory. So Sarah is the manager for John, and Sarah is the manager for Jane. Sarah is the manager for Mike, and again Chris is the manager for Amy. Chris is the manager for David. Emily is the manager for Sarah. Okay, if you see, Sarah is acting as the manager, and also she is also acting as an employee. So this happens in a company, right? In a company, your boss is going to be what? An employee for some other boss. For example, so if you are since you're doing the college, so the active your active, what we call it as they call you as juniors if you are doing the first year. Example, let me say there is a batch like 2021 or 2021 batch, okay? And you are 2022 batch, okay? You are 2023 batch. You have three batches. So 2023 batch must be juniors. Juniors for what? They must be juniors for the 2022 batch, right? And with respect to 2023, okay, 2022 batch, they are seniors. They are seniors for 2023. Okay. And again, this 2022 becomes juniors for 2021. Okay, so these 2022 students, okay, the students who have like completed their graduation 2022, they are going to play a role of what? Senior role with respect to 2003 students, and junior role with respect to 2021 students. They're going to, depending upon from which perspective you're going to see them. They're going to play the junior role as well as what? Senior role, depending upon the perspective. If you look at them from the 2023 perspective, they are seniors. But if you look at them from 2021 perspective, they are going to be juniors, right? So one set of students can play different number of. Likewise, and an employee can be a manager, and that manager is going to be what? Going to be an employee for another manager. There is a chain, right? There is a chaining game. What kind of chaining? Or if you take John as an example, John's boss is Sarah. Okay, Sarah's boss is what? And Sarah's boss is Emily. Okay, and Emily's boss is, if you see Emily's boss, there is no such boss for Emily. Emily is null. Emily's boss is null. No such boss. If I combine all these three, if I combine all these three, every employee, every manager or every teammate or every what we call it as team leader, everyone are employees. Again, under employees, there are some categorization to look after the team. And if you have such kind of data, if you have such kind of hierarchical data where one employee is mapped to another employee internally, even though they are the common entities or they are the common, they are falling under one category, but they are getting mapped, between two employees. Okay, a kind of hierarchy, a kind of senior hierarchy. Such cases you can go for this. You can go for these queries. Is what? Comparing multiple column values to each other within the same table. With this example, okay, it might not be much clear. Let me take another example. So another example would be something like this. Okay, I can say write a query, to display employees who are who are joined before their managers. Now look at this query. If I look at this query, I need to deal with the employees and the managers. I need to deal with the employees and the managers, right? So I need to display the employees who have just joined before the managers. Right? For example, let us say that if there is an employee like yes joined in 12th July, something like 2024, and this employee as there are some let me take another employee 13th December 2021, okay, and 11th April 2000, right? Let us say that these are the employees and their joining dates, right? And this is the manager joining date. The manager has joined something like date is 04 August 2023. This is a manager joining date. Okay, I want to display employees who are joined before the managers. Okay, this is the manager joining date, and these are the list of employees joining date. Right? I need to do a comparison. I need to do a comparison in such a way that, right, I need to extract. Okay, if you take this as an example, 2024, which is after 2023, so this will not be satisfied. And if you see 2021, which is before 2023, I can take this, right? This is 2020, which is before 2023. I can take this, so I can conclude that I can take this data and map this higher date according to the respective employee names and conclude that these two are the employees who have joined before the manager. Okay, this is a required this is the expected output. How I can draft the query for this? The query would be like something like this. So I can select employee number, employee name, select start from. These are the employee list. So what I am doing, I am selecting e dot employee name okay, as employees. Okay. E dot hire date as e underscore date of joining, comma m dot e name as manager, m dot hire date as manager underscore date of joining. Okay, I want to display see these four columns. One column is employees by the name of employee. Second column is by the name of E underscore D of J. Manager column and M dot M underscore D, date of joining. Okay, from employee E joining condition employee M. So by these two virtual tables will be created. One is by the name of E, second one is by the name of by the name of M. After this, I'll be taking the on clause on. Now see the joining condition. Okay, M dot employee number. So I'm taking the employee number from visual table M. I'm comparing that with E dot what MGR. So this comparison is going to map the employees with the respective the same query, just like the previous query. But I'm going to add what I'm going to add the and condition. Right? My condition says first you look for this and also try to see if the employee hire date employee hire date is what is somewhat you know uh, lesser than manager hire date. That's it. Okay, and you get to see two virtual tables. Okay, one is the one virtual table by the name of him, second virtual table by the name of he. Two employee virtual tables will be there, but you're just comparing the employee number. Where is employee number? This is employee number. Okay, to what? To manager. The employee number is getting compared with the manager, but between the virtual tables, not the same within virtual tables. Along with that, for example, let us say that Sarah. Okay, the Sarah will be getting compared with manager. Right? Along with that, you are also comparing. Okay, if the employee hire date. Okay, if the hire date of the employees, right, is lesser than manager's hire date. You just fetch this query. Something is missing. What is it? Okay. What is missing? Like error at line number 1. Okay, this one, guys. On select E dot E name as employees, E dot hire date as E of him, M dot employee name as manager, M dot hire date as M underscore D of J from EMP. E join EMP M on M dot employee EMP number equal to E dot MGR and E dot hire date is lesser than E dot date. What is it? M dot employee. Okay, one I did not add a space. Okay, that's the problem. Now you see this is the resultant output. Okay. John has joined before Sarah. Jane has joined before Sarah. So these are the managers for John and Jane. Okay, I am able to get the joining date. What joining that I'm getting. So it is confirmed that they have joined even before their managers. By if you go by the date, okay, if you go by the joining date, please confirm that they have joined even before their managers, right? And Ami, manager of Ami is Chris, right? But Ami has joined before the manager Chris, 2017. See, look, if you just validate the data, it is looking like the data is valid. Okay, so just I am playing with the condition, nothing else. Okay, I'm playing with the condition. If you're getting any kind of confusion, take two virtual tables and do the comparison. Okay, especially you just have to focus on this. especially on this part, the joining conditions. Right? You're playing with two different virtual tables. That's it, nothing else. Apart from that, you do not have to see, anything else. Right? So this is all about what? This is all about the concept of self joins. Right? So by this, I can conclude the self joins, and if you want, you can try. You can try some examples, from your side also. So I can conclude that this is all about the self join. The next thing. Okay. So till now we have discussed about what? We have discussed about how to join two tables or how to work on the same table. So say self join is going to help us to work on the data that is falling within the same table. If you have a column in a table, if you want to compare that column in the same table, you can go for self join. But if you are dealing with two different tables, and you can go for the norm. I mean the what we call it as the equi joins, inner join, outer join, right? Natural join and cross join. What if I want to deal with this three different tables? What if I want to deal with three different tables? I mean more than two tables. Okay, I want to join. How to join? How to join more than two tables? How to join more than two tables? Okay. So let me give the syntax. Okay, syntax for non-ANSI format. Non-ANSI format, the syntax is select star from. Okay, you are going to deal with many number of tables. You have table number 1, right? Comma, table number 2, comma, table number 3. Likewise, it keeps going. Table number 1, table number 2, and you have what? You have table number 3, right? There, condition 1 and condition 2 and condition 3, and it keeps going. So in the non-ANSI format, to join two tables, okay, we just select the two tables, and we just use this where clause, and we apply the condition by using this and operator, right? We just apply the condition by using a AR clause and operator, right? But if you see, the and operator is getting repeated subsequently, right? So because you are dealing with what? You are dealing with three tables here. So there will be three conditions and two AND operators. Keeps going. If you are dealing with 10 tables, you apply condition, and again that condition will be applied on another condition. That condition will apply on another condition. A chaining condition, a kind of chaining condition. Right. So this is the same like the working with non-ANSI or inner join, where you take only two tables, but here you are taking more than two tables. That is the only difference that you have here. That is the only difference. Apart from that, you do not have what? You do not have any other. For example, you already know that we have. Okay, let me go and see this example. Here. Clear screen. Select star from course. You have the course table. You have select star from. After the course table, you have the student table. Or student. Your students table. You have the course table, right? And I'm going to create another table like, so create table, because we are going to see the non-ASCII format of joins by using more than two tables, right? Create table. The name of the table is going to be the register. So you have what? You have something like a register number of integer type, and you have something like a registered date, of date type, we have something like CID of teacher type. Three columns I'm taking. Okay. Then I'm inserting values. Insert values to insert into register values. The values are going to be like 1021, comma. The joining date is going to be like registration date is going to be like 1st July 23. It should be in single quotes. It should be in single quotes. The third one is 1. Okay. So 1022. Here I'm taking the 12. The course ID is 2. Okay. Then 1023. I'm taking same 12 only. The course ID is 4. Select star from register. So I have the register table ready. Okay, now I have the course table, I have student table, I have the register table. Right? Select a star from students. Select a star from three tables. I want to join these two tables based upon the common column. So the common column is what? Common column is here. The common column we have what? ID, right? ID, CID, CID, ID, CID, CID. And if you see, I have last time in the last session, I think I have deliberately changed it to what? Changed it to the instead of ID, I have just changed it to CID. Instead of CID, I have just changed it to ID. Right? So let me rename that. Alter table. What is it? Course, course, course. Rename column. What is old column? ID to start from. Now I have three common columns. CID is a common column for the course table and for student table and for the register. Now I am able to extract the common column. Now let us apply the non-ANSI format for equijoins. Okay. What I can do, select star from student, yes, students, yes, comma, course C, comma, register R, okay, where s.cid, okay, s.cid equal to c.cid and c.cid equal to r.cid. Okay. This is the a kind of the chaining operation, kind of chaining and operation. Right? For non-ANSI, you don't use this instead of on, you will be using where. But for the non-ANSI, there are no join keys. There are no joining keys. If you recollect the things that I have explained for the non-ANSI format, no join keys will be there, and instead of on, you will be using where. Right? So you are selecting the CID columns on student table and the course table, right? You are comparing. So somewhat it is going to return. For example, if this is returning true, right? And there is another comparison like c.cid equal to r.rd. Kind of chaining is happening here. Only if two conditions are found to be true after applying the logical and operator, right? The resultant table will be joined. Okay, so if you see the common columns, 1, is part of the students table, and the same one is also part of what the course table, and the same one is also part of a visitor table. So those three rows are joined together to form the resultant table. And again Ramesh, 1 1 1, and again Suresh, 2 2 2. Look at the CIDs, okay? The common columns are joined, right? So this is the syntax. So this is how the non-ANSI format, the query for non-ANSI format can be written. Okay, this is the query, right? Then syntax for ANSI format. So in the ANSI format, we just change the two things. Okay, you apply the joining condition. The first thing. The second thing is you will be using what? You will be using this instead of where clause, you will be using on. That is the only condition. And if you want to look into the syntax, okay, the syntax is going to be like this. Select star from, select star from, okay, table name one. You have the join key between two tables. You always have the join key between the two tables. Table name 2, right? Or join condition. Table name 1, join key, table name 2 on join condition, right? Likewise, this is going to get repetitive. Next one is join key and table name 3 on join condition. Next thing is join key, table name 4 on join condition, right? So this is going to get repetitive. Likewise, it is going to get what? It is going to get repetitive. How long it is going to get repetitive? Infinite number of times. Okay. At last, we will join key, table name n on join condition. So this is this is join key, join condition. Okay, this is join condition 1. This is join condition 2. This is join condition 3. The table name is 1. Join condition is going to be n minus 1. So this is the pattern, right? So if you see, if you select table name 1 and table name 2 on a join key, right? The join condition is going to be the first join condition, right? And for table name 3, for table name 3, right? I mean, after the join key, the table name 3 follows, right? For the join condition is 2, condition is 3. After applying the joining key, between two different tables, you are applying the joining condition, right? So first condition is going to be 1 for these two tables, right? And for this table, the condition is going to be 2. For the table number 4, condition is going to be 3. For table number 1, condition is going to be n minus 1. Chaining joining condition is happening. On the resultant set, you are again using the join key, right? On a table number and the join condition. And for this resultant set, you are using the join key, the table number on join condition. Again, for this resultant set, you are using the join key, table number or join condition. Right, so let me put it in a different way. We'll see one example on this, so it will be clear. Same example I'm going to take. Example of this is what? We select star from student S. Okay. So I need to apply the joining condition between two tables. So inner join I'm taking. Inner join core C. Okay. First I will, if you have three tables, I will be taking the first two tables, student table and the course table. I will use the join key, followed by I will be applying the join condition here on s dot cid equal to c dot cid. Followed by I will be again using the inner join register R, okay, on c dot cid dot cid equal to R dot, that's it. Okay, so first select two tables. Between these two tables apply the join key, inner join. Two tables are here, inner join, and apply the join condition on these two tables. Okay, the resultant set, on the resultant set use the join key, right, and use the next table register R and apply the joining condition. And if you have another table, okay, this will be just going like the chaining conditions, chaining join conditions. There are very in real time there are few areas we'll be using this, right, but understanding this is going to be not going to give you some the broader picture about the joint concept. So this is all about the the all kinds of joints that we have discussed. Okay, and tomorrow the classes is going to be like sometimes, okay, let me clear this. Now focus here. I am asked to create a table, create table employees, create table employees one I am taking. Okay, so what I am doing it here, I am taking the EID as employee ID, which is of integer data type. Second one is employee name, which is of worker2 data type. The third one is what? Salary number, which is of what? Which is like 9, 2. Okay. The fourth one is what? Age, integer. I have taken the 4 columns, right? The first column, second column. Now see the problem that we face here. It won't look like a problem, but it is a problem. What problem? Let me insert the values. Insert into table employees one. The values are like, I'm going to prefer to insert 1 comma employee name as Suresh, comma salary something like 10,000, comma age is something like 27. Insert into the table name values. Into values. A one row creator, right? So if I just insert the same data over and over again, right? I have inserted the same data over and over again. Select star from employees. Okay, same data is getting inserted over and over again. But this is causing what? This is causing the data redundancies. Duplicate data duplication is one thing. One problem we are facing. So I'm not supposed to insert the same data again and again. First thing, because since Oracle is allowing me to insert the data again and again because of the way that I have created the table. My table has been created in such a way that this table is not secured enough or not protected enough to ensure that the duplicate data are not allowed, because that is how the table is created. Okay, and the second thing is, so this is fine. Okay, let us say that this is fine. Second thing is, okay, I want to insert values. something like null, 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 null. I'm inserting the empty values. Okay, for 4 times I'm inserting. If you see, select star from employees one. Okay, so you have the visible data and you have the invisible data, which is as null. I'm able to insert the empty values also. Right? It is not necessary. I should place some restrictions on this. Restrictions on the table that duplicate should not be allowed and the null value should also be. It should also not be allowed. But if I am allowing the null values, it is just like my table is not good enough to store the data, and is also going to increase the size of the memory. Unnecessary, the size of the memory is going to get increased, right? And the performance wise, it is going to be down. So many problems that we are going to face. Why we are going to face so many problems? Because that is how the table is being designed. Now look at the third thing. What I am saying, I am taking another employee. Okay, let me say that I am taking the valid employee. This time Ramesh. Ramesh is the valid employee information. This time I'm taking his salary as 15,000. Okay, I'm taking his age as 2,700. Inserted. See, if you see, 27 is fine, 27 is I'm saying 2,700. Do you think there will be any person by the age of 2,700? But still, I am allowed to enter this kind of misinformation. Maybe the person might have entered the information accidentally. I need to do kind of checking, right? A kind of checking so that a person can enter the age between 0 and 100 or maximum 120. 120. But it is allowing me to enter an age is not even, which is can't even imagine, right? Why am I able to enter this age? Because this is how I have created the table. So I need to ensure that I'm not entering the duplicates, I'm not entering the null values, I'm entering the right kind of data for the respective columns, right? I want to do such validations, right? So these validations can be done while creating the table itself. While creating the tables, I need to write some validations. Okay, next to the data type, I need to write something next to the data type so that this can be avoided. These things you will understand tomorrow. This kind of concepts you will understand tomorrow. What concept is that, and how we are going to implement that so that these things can be avoided. Right. So we will continue this in the tomorrow's class. Right. For now, we will stop the session. We will see tomorrow. Thank you.